Here we have a trig equation to solve, and it didn't say it, but it should be finding solutions on the interval from 0 to 2 pi. So the first thing I'm going to do is combine the trig functions. So I'm going to add sine of x over 2 to both sides, and that will give me 2 sine x over 2 equals square root of 2. And the next thing I'm going to do is isolate the trig function, so I'm going to get rid of the 2 that's in front of it, and I now have sine of x over 2 equals square root 2 over 2. And as I look at that, it's not an x, it's an x over 2. I'm going to think about that as theta for just a minute. And so I'd have sine theta equals square root 2 over 2. So this is asking where on the interval from 0 to 2 pi is the sine square root 2 over 2. So as I think about that, sine is positive in quadrants 1 and 2, and I know square root 2 over 2's are multiples of pi fourths. So I'm going to have an angle in quadrant 1 and in quadrant 2 that are multiples of pi fourths. So that means theta either equals pi fourths or theta equals 3 pi fourths. Now I'm going to go back to my original angle form, which was x over 2, so I'm going to replace the theta with x over 2. So either x over 2 equals pi fourths, and as I solve that, I multiply both sides by 2 and find x is 2 pi fourths, which reduces to pi halves, and that's one solution. Or x over 2 equals 3 pi fourths, and I multiply both sides by 2 and reduce, I would get x equals 3 pi halves. So there are my two solutions to this equation on that interval from 0 to 2 pi.